Hello everyone, my name is Renaud Bougueng, and today I'm going to present my PhD thesis on the subject of design and evaluation of multi-track computer-assisted MIDI composition interfaces. I'm first going to present an introduction of this thesis with the objective and the research questions. Then I'll present the contributions that we've made to the research field, and I will conclude with a conclusion. Computer-assisted composition is a field of research that is concerned with algorithms, programs, and softwares that can assist users and music composers at solving music composition tasks. We have an example of Yannick Xenakis' Metastasis composition in 1955, which made use of chance operation and mathematical techniques in order to compose music. Computer-assisted composition is a subfield of creativity-assisted software, which range from purely reactive to completely autonomous. There are many ways to represent musical information. Our thesis focuses on symbolic music notation, in particular MIDI, which stands for Musical Instrument Digital Interface. MIDI is a communication protocol for computer devices to exchange musical information with each other. We have an example of the MIDI data protocol on the left bottom of the screen, where we see a status byte and two data bytes. The status byte encodes the state of the note, whether it's on or off, the MIDI channel that the note is being played at, so it's correspond to the track level as well, the note number in the data byte that represents the pitch, and another data byte to represent the velocity or volume or amplitude of the musical signal. And on the right side, we see work by Raphael Leon for a framework for multi-track segmentation of symbolic music, where they are able to segment a musical score into MIDI notation. The spectrum of CAC interfaces is quite large and varied. Here we provided a very small sample of existing CAC interfaces to show a coverage of the designs from 2001 to 2023. In particular, CAMU, which stands for Cellular Automata Music Generator, is a CAC system capable of generating MIDI compositions following a cellular automata algorithm based on Conway's game of life, hence the interface and the controls provided. In contrast, DeepMind Lyria by Google DeepMind in 2023 is a text-to-audio transformer system which allows users to enter text and to manipulate controls in order to generate music in the audio format. Our thesis was grounded around two key pieces of observation. The first one is that recent progress in AI capabilities has made it possible to explore novel CAC system designs and development that can benefit composers. At the same time, we found that few CAC research work have critically examined the effectiveness of their system at assisting music creation. This has generated our research goal, which is to design, develop, and study interactive AI-based CAC system for multi-track symbolic music, focusing on two user groups, novice and expert composers. This goal was, out of this goal, we arrived to two fundamental research questions. One question focusing on how we can interface computer-assisted composition system database that use AI. And the second question that focuses on the evaluation of those built CAC systems. Specifically, we were interested in construct of usability, user experience, and technology acceptance. These questions were further broken down into sub-questions. On the interface side, we were interested first in characterizing design space of what kinds of CAC interfaces are possible. Then looking at how to design for interactive machine learning process, which I'll talk about later, and also how to interface transformer-based music model, which became quite prominent after the attention papers. Secondary, on the evaluation side, we also produced sub-questions that specifically look at each of the constructs: usability, user experience, and technology acceptance. And user experience focusing on specific deeper questions such as the level of trust, the level of authorship, level of flexibility. And we also added a fourth question which focused on benchmarking evaluation, because this is an important part of being able to advance research field, is the ability to be able to compare and contrast evaluation within our studies, but also across studies. So this is something we were interested in exploring. In terms of methodologies, our work centered around the usage of the design science research. Design science is the design and investigation of artifact in context. That means that there are two parts to this methodology. One part where we focus on engineering design and implementation of actual systems. Another part where we conduct scientific and systematic evaluation, investigation of questions related to these systems. In this case, focusing on mixed method research. Because of the multidisciplinarity of the CSE field and the questions around interface that we asked before, we further deepen our methodological grounding by looking at questions around interaction design, using research redesign and technical practice research to uncover these understandings. And equally on the evaluation side, we went further into artistic-based forms of evaluation, capturing research creation methodologies in order to add substantial answers to the questions of evaluation. All in all, we contributed 8 publications in the form of 3 conference papers, 1 short paper for a conference, 2 workshops, and 2 journal papers. These contributions really centers around 2 system contributions, Apollo and Calliope, and 2 evaluation studies that we conducted from these systems. Now let's look at the contribution of our research to those 2 central questions of interface and evaluation. First, we started with a survey of the CSE field, trying to capture and understand the nature of computer-assisted composition systems as phenomena. This survey covered CSE systems that have been developed across time from 1963, since the originating work from Lejail Hiller, all the way to 2023, effectively covering 60 years of CSE research. Out of this survey and investigation, we extracted a taxonomy that best describes CSE systems as phenomena. There's 4 dimensions. The first dimension is the composition problem, meaning the task and the scope that the system covers. Then the architecture, that is the algorithm that the system uses and the data representation that it uses. Then we looked at the human-machine interaction, so the user interface of the system, the interaction role and flow, as well as the ecosystemic context, which captures the sociological context of developing CSE system, which is less talked about in the field. Constructs such as deployment platforms, authoring community, what is the target audience, licensing, etc. So out of this survey, we collected 115 CSE systems. Those systems were then classified across the taxonomy that we produced to demonstrate not only its applicability, but to actually provide an original contribution to the field in this journal paper, which effectively categorized these 115 systems across the taxonomy. Furthermore, we provided statistics of CSE system development throughout the 60-year period, and we we identified challenges and opportunities to the CSE field from this research. In particular, challenges around opacity of machine learning and deep learning method when developing CSE systems, consideration for user groups when we do design, exploring CSE composition workflows, which becomes more possible as we're exploring new designs. Issue of copyright ethical concern around data, but also around CSE use by users. and evaluation and benchmarking challenges. From this broad understanding of the CAC field and a better understanding of the design space of what's possible in terms of interface and system, we then embark in the actual step of developing CAC, novel CAC systems. We had two contributions here. The first one is Apollo, which is a system that interface the interactive machine learning, effectively allowing users to train and generate in an interactive way. The second contribution is the Calliope system, which interface an inpainting technique with track level controls. For Apollo, we developed a desktop environment system that can facilitate the usage of corpus-based style imitation for music composition. What that means is that artists can upload a small data corpus of their own in the Apollo interface, as we see on the right side, and with the Beatle, with a subset of the Beatles song. They can then select the algorithm that they want to use, that they want to train on this corpus, in this case, the music VAE model. They can select specific files, MIDI files in that corpus, and they can click on the train button that will train the music VAE model on this corpus, and they can use the train model after that to generate. In this case, obviously, the controls that we see for the training essentially create a fine-tuning of the music VAE model. In order to develop Apollo and to design the interface that you just saw, we first embark into an exploration of the design space itself of interactive machine learning. We first looked at interactive machine learning workflow for CAC, where the user add music, train, generate, and listen, and the loops that are associated with that interactive process. Out of that, we explored the various ways that we can organize design affordances of the interface to promote or suppress particular possibilities of the human AI interaction. So we contribute an annotated portfolio of 6 design concepts that best describe the design space of interactive machine learning as a design material. We ended up using this particular design concept which we title technical, being geared towards more expert users for the usage of Calliope, of Apollo, sorry. Out of these design concepts, we extracted specific dimensions that we believe best describe the design space: interactivity, intelligibility, and machine autonomy. We then categorize the design concepts across those dimensions, effectively being able to start to understand in which way the design affordances on one side of the concepts interact and or influence the level of interactivity, the level of intelligibility, and the level of machine autonomy of the design. We then plotted these data across the design space to show not only how the 6 design concepts that we contribute covers a reasonably large spectrum of the design space, but also that they allow us to better make sense of how we can design interface for interactive machine learning and how those design might impact the various properties, the key properties of controls that the user has. Then we engage in the development of the Calliope system. Calliope is a web application, free to use online, that implement inpainting for batch generation using MMM. MMM stands for the MultiTrack music machine, which is the algorithm that is used here. Calliope also allows automatic ranking of generated pieces. In order to better understand the Calliope system, we have to talk about inpainting. Inpainting and infilling is a computer science task of automatically filling the blank of a piece of content. It's a task that originates from image generation work such as UAR in 2018, where we see on the left side an original set of image, then we remove parts of the image and we ask an AI algorithm to fill in the blank of the image, effectively reconstructing the image. But we see that this reconstruction is slightly different from the original because it is a synthesis of new visual information, effectively generating in such a way that we maintain coherency across the data. So this is the same approach that is used in musical inpainting in the case of Calliope with the MMM model, where the user is able to select parts of MIDI tracks that they want to regenerate or reconstruct and essentially get new musical suggestions, new musical examples that still maintains musical coherency and consistency across the whole song. So the MMM model generates new musical content that takes into account not only horizontal information, that is notes that comes before and after in the track, let's say in the grand piano at the channel tree, but also take into account vertical information, vertical dependencies, so data that is found in the other instruments. And finally, the MM model also takes into consideration the instrumentation. Generating for drums versus generating for saxophone or piano will yield different results because the model understands the particularities of those instruments. It is trained on the MetaMIDI dataset, which is a dataset of 500,000 MIDI files, and it allows for rich multi-level controls. We can see in the image on the right that each track has controls for density, polyphony range, and note duration. Here we can hear an example of Calliope on a piece of Mozart music. So from this work that we conducted developing Calliope and Apollo, we then later reflect on the engineering and design activities that we conducted developing these systems. This was a conference paper for the AIMC where we contributed an annotated portfolio of design interfaces that captures the different iterations of the Calliope systems. In particular, we conducted a design research study in 2023 with Northeastern AI-ACI student and two professional musicians in a think aloud method format where the musicians use Calliope to work on their own music projects that they imported into the system, and out of which the student proposed this updated UI of Calliope, which part of it were integrated into further iterations of the system. After developing these two systems, we then moved to the evaluation exploration, trying to understand how can we measure the effectiveness of CAC systems that we built. We had two evaluation studies, one focusing on experts with 18 participants, evaluating the MMM Cubase, and then the second evaluation study looking at novice with 98 participants spread across two systems, the Calliope system and the MMM Cubase version 2, looking at user experience, trust, authorship, and technology acceptance. Some of these constructs having never been evaluated in the past. So in the first evaluation study, we looked to evaluate three specific composition tasks: an arrangement task where the participants, the experts are given a single track, such as a drum sequence, for example, and they have to complete the song by adding new tracks using the the MMQ-based system, a remixing task where they are given a fully fledged song and they have to produce a variation of that, an original composition where they have to start from scratch. They choose a genre or a style of music that they want to create, and they work with the AI plugin to make the composition. For the evaluation, we used the standard usability scale to measure evaluation, to measure usability, sorry, the creativity support index by Cherry to measure creativity support by the plugin, the technology acceptance model to measure acceptance, and a set of qualitative surveys to measure the user experience. The MMQ base was also built intentionally with a single parameter called temperature, a typical parameter found in neural networks, which influence the level of stability in the sampling of the data. In terms of results, we found that overall, the usability and acceptance level of the system were positive for both hobbyist and professional experts. The one parameter design did limit expert creative control as expected for a design of the sort, but we were quite surprised that the MMQ base did help advance expert creative process via ideation and also solving creative blocks. This was something that was reported by experts that had used the system. In terms of the user experience themes, we ask questions across the topics such as trust, authorship, flexibility, challenges of using the system, workflow features, concern, practical benefits, quality of generated music. And we compiled the different themes that we found. Themes such as repeated generation, where the expert reported having to generate multiple times in order to find what they liked, which was a main issue that connects also with the parametric control, the lack of parametric control of the system, which was an anticipation of the one parameter design that we chose. But this was done in order to establish a benchmarking for evaluation. This was the goal of this first study with respect to the fourth research question, sub-research question of evaluation, to try to provide a methodology that will act as a benchmark, as a baseline for us to be able to conduct further evaluations. We also found, as we said, themes such as surprise and novelty, where experts were at times pleasantly surprised by the result of the system, giving them new ideas to run with, and also a report of co-creation and creative control, where experts talked about the fact that they felt that they were collaborating with the system because the system was not as good as they could be in generating very useful melodies, but were also able to influence their creative direction in the making of music. And on the controllability level, we found that in terms of ease of control, the results were quite average with a large standard deviation, pointing to the issues of controllability with the one parameter design. And when we asked the expert whether they would want more control, we saw an overwhelmingly strong positive answer. On the creativity support index, exploration, engagement, and enjoyment were quite positive. Expressiveness was the lowest performance metric, again hinting at the limitation of one parameter design in allowing the user to creatively express themselves. Then we moved into the second study, where we focused on evaluating novice composers, looking at two systems this time, the Calliope system, which is a standalone system web application on its own, and the MMQ-based version 2, which again is a plugin embedded in the Cubase software, which is a DAW, a digital audio workstation. We focused specifically on the arrangement task, and we ran the same protocol for methodological evaluation on usability, user experience, and acceptance. Here we can see an example of MMQ-based version 2, where we provided much more parameters that are available in the MMM model for the novice to use. So this real-time demonstration of the use of MMM in Cubase shows the generative power of the algorithm to produce coherent musical information in real time. We then looked, when we look at the result of this second evaluation, where we had separated the novice into two major groups, early novice, which were users that had always wanted to make music or have been interested or tried to make music, but never really got into taking a DAW, working on a song, versus the skilled novice, which were characterized by those that have actually sort of get their hands dirty and try to make music. What we found was that both system, Apollo, Calliope, and the AMM Cubase version 2 were usable by both groups, except for AMM Cubase for the early novice, which was under 70, which is a borderline result on the standard usability scale. This was corroborated by qualitative data that we collected on the survey questions where 25.6% of novice users reported being overwhelmed by the Cubase software. We explained this by the fact that Cubase software, the MM Cubase being a plugin inside the Cubase software, which is highly complex and have a lot of parameters, this contributed to the challenge. We actually found a statistical difference in usability scores between Calliope and MM Cubase for the early novice. On level of controllability, this time we found the result drastically different from the previous study. The novice users found across both interfaces that there was sufficient controls, covering note duration, repetition, musical genre, and also the musical style. The user reported that they were able to use the controls comprehensively to produce music, and that they didn't really want more control in the main interface, but they did point out that there was a lack of depth of control. Novice users wanted more advanced control, such as control over rhythmic patterns, control over specific chord progressions, time signature, keys, etc. And in terms of user experience theme, across the same set of questions than in the previous study, we found that novice users report on both systems a high trust for these systems in terms of helping start ideas, the ability to generate musical ideas that can start projects. They also reported in the difference to experts in terms of the workflow. They found the workflow efficient and structured. Many novices reported that because of the lack of experience making music, and the fact that they felt the system is capable of creating musical content that they would not be able to do on their own, that is much better than what they would do. They found that the system was thus efficient, where they can provide constraint and they can provide a request, and the system can generate that. But also because they lack experience working with the creative process of making music, they found that this approach of working with an AI plugin such as MM Cubase or a software such as Calliope allow them to naturally have a structured workflow because they could kind of follow along with the process that the AI has structured around. A drawback of that was that many novice reported uh, um, feeling minimal authorship over the musical result. Novice users reported that because they were mostly clicking on buttons and the MMM model was generating the actual musical content, they felt at times that they were not the author of the final result. So this is something to take into account. A minority of users reported that they felt that they were significantly author, or that the authorship was partial, because it still felt like some users say, even if I'm pushing the buttons, I'm still driving the creative direction, and the MMM is sort of just executing. So I'm sort of the musical director and executing. So therefore, I still have a strong degree of authorship. The repeated generation theme showed up again, this issue around having to generate multiple times to get the result that they wanted, although much less than in the previous study. And finally, there was concern being reported around musical diversity, where novice users highlighted the fact that they had to over-reliance on this type of systems meant that the musical result will lose diversity, but also that they felt like losing the ability and opportunity to develop their skills. Many of these novices taking on an activity such as making music in order to develop their skills and become more proficient at making music themselves. And finally, in terms of technology acceptance, we find that the results were quite positive. In fact, 76.9% of novice reported being open to use MMQ-based version 2 in the future. And likewise, we had 72.9% for Calliope. And now, after all this evaluation work, we also look, as I mentioned earlier, into evaluation from an artistic point of view. And so we produced this journal paper. I produced this journal paper where we looked at the entire set of musical activities and works that were conducted at the Meta Creation Lab between 2018 and 2024 using the systems that were built by the lab. Systems such as Apollo, Calliope, MMQ-based version 2, but also MMM for Live and MMM OPZ. For this investigation, we used the research creation method. Research creation integrates a creative process, experimental aesthetic component, or an artistic work as an integral part of the study. And we did this in three specific ways. First, us as researchers, also being musicians, we took on the dual role of not only researching and building CAC system and evaluating them, but also putting our musician hat and using the system to create music that we can then reflect on from an artistic point of view. We also conducted third-person account research creation work where we took those systems, put them in the hands of artists, distribute them in the hands of artists from different backgrounds, and let them use these systems in their musical practice and evaluated the results. And finally, we also took a participatory design approach where we invited artists to collaborate with us. We brought artists into residencies and guided environments to collaborate on working with the system and understand as another way to artistically evaluate the effectiveness of CAC systems. Out of this process, we contributed these 7 musical projects, out of which I'll focus on the 2 where I was the most involved. First, the Apollo Music EP. In this musical project, we were interested in seeing the extent to which the Apollo system that we've developed was capable of being used concretely in proper musical practice of making electronic music. So what we did was we created a corpus in the style of new disco that we put in Apollo, and we used it to generate multi-track music, MIDI parts that were uploaded in Ableton Live. We use OPZ for sound design and the BCF 2000s for mixing to produce the EP of 4 songs, out of which here you can listen to the Hard Disk Fever song. And in the second piece of artistic project that I was involved in, which was a Calliope's entry for the AI Song Contest in 2022, we looked at the question of whether MMM could be used to produce a song from scratch with very minimal editing. This was the artistic problem that we asked ourselves. And to do this, we started with Calliope and a blank slate, and we generated to find a central theme working around the musical genre of synthwave or retro synth. Then we used the main theme to generate variations in Calliope. We took all those multi-track MIDI files, and we imported them into Ableton Live. Over there, we made adjustments, minimal editing adjustments. In fact, most of the editing that we did were around readjusting the octave levels to match this instrument set that we had chosen. This gave us the AI song contest entry, which we can listen to now. So this longitudinal report as a journal paper of the musical activities that were conducted at the Meta Creation Lab using the CAC system demonstrated new composition workflow for artists to make music using AI-based CAC systems. We also discussed in the paper musical quality and coherency, some of which you listen to here in the examples. We covered technical challenges that arise from conducting research creation and participatory design work, where we put research prototypes in the hands of experienced professional artists, helping us refine those systems and improving their effectiveness. And finally, we also discussed in the paper the discovered diversity in use of CAC system by professional artists, given the diversity, given the diversity of the artists, we had artists that use some of our systems in unexpected ways. And all in all, in conclusion, we reviewed the contribution that we provided for this thesis and the research question. We contributed technical and interactive dimensions of CAC by addressing the design, development, and evaluation of novel systems such as Apollo and Calliope. We also bridged AI research with user-centered design, ensuring that CAC tools remain accessible, expressive, and adaptable to diverse creative needs. On the evaluation side, the evaluation we conducted highlight key results in technology acceptance, making a case for interactive design methodologies that prioritize user experience and workflow integration. And finally, the artistic dissemination that we've demonstrated of CAC-based music works demonstrates the real-world impact of CAC research and AI technologies, reinforcing the role of AI as a creative partner rather than a mere automation tool. And so future work that we see in the field are around issues of developing more robust standardized methodological framework, a deeper investigation into phenomenological grounding for user workflow with longitudinal engagement and perceived creative authorship, developing more interface like Apollo for small data models tailored for individual artists, which we see this trend starting again now. And in Calliope, we think there should be more development on the interactive visualization of generated musical alternative, as this remains an important challenge. And we also ask the field to investigate underexplored system typologies from gaps in the CAC taxonomy that we highlighted. So in conclusion, the central question around AI in society still remains. We have to rethink more broadly how human intelligence, creative agency, and technological systems co-evolve. This is as part of the context of computer-assisted creativity, part of the bigger question of how do we meaningfully design and evaluate for human AI interactive systems, enabling effective computer-assisted creation across modalities, which includes text as well as visual domain. Thank you.